All right, guys, we're going to take a look at real world problems. These ones can get a little bit lengthy because of the explanation, but it's not that big a deal if you kind of get used to it. Okay, so this is domain and range, appropriate domain and range for real world functions. All right, so Carson is standing in the stadium. He has the option of running up a staircase or down a staircase for exercise. Biggest thing about this is you need to picture yourself doing it. So here I am on some steps and I can run up or I can run down, okay? The way that works, that function is represented by that, will determine how many calories Carson will burn if he runs up X steps. Use a negative value for X if he runs down the stairs. If I'm going up the stairs, it's positive. If I'm going down the stairs, it's negative, right? Find and interpret the given function values and determine an appropriate domain for the function. All right, so f of negative 45. So negative 45 is your X values. In my problem, what does the X values represent? All right, so Carson will burn up X steps. So X steps would be my negative 45. So what does that mean? That means I'm going down 45 steps. All right, now I need to evaluate the function at this point. So I'm going to go ahead and type it in. So y equals 1 divided by 25. And then parentheses. And I know I have absolute value here. So I'll put absolute value 5x. And then plus 3x. Close parentheses. So absolute value is A, B, C, D, and then this A with the absolute value marks. And this is what my graph is looking like, right? This is what my graph looks like. Now, at when X is negative 45, and I can go to when X is negative 45. See, now, the thing is, we're doing this in the graph, I can't be sure exactly where it is, right? So that's negative 49, negative 48, negative 46, negative 43. I mean, I'll be over here forever trying to find negative 45. So what I'm going to do is I'm actually going to work it out. To work it out, I'm going to control paste. And all absolute value means is take the positive of whatever this is. So where I see an X, actually, I'm going to paste this out. How many questions do I have? 3 times. 3 times, because X is 3 different values. That one, and that one. All right, so I'm going to paste it out 3 different times. And then I'm going to replace where I see X with parentheses, open and close parentheses with the number, negative 45. Here with parentheses, where I see X with negative 45. Now, and then, ooh, I didn't mean to do that. Let me copy and paste, I apologize. So again, where I see X, open and close parentheses, negative 45. Where I see X, open and close parentheses, negative 45. All right, so Y is equal to 3.6. I'll do the same thing. Actually, I will copy and paste. Oh, golly, if I do that one more time. Where I see X, negative 45. Where I see X, open and close parentheses, negative 45. And what I'm going to do is I'm actually going to copy this so that I don't have to write it. I can just, it'll already be here. So 3 times. And now I'm going to change the negative 45 to 15, positive 15. So let's change that to 15. So just basically where the X is. And on the last one, I'm going to change it to 42.5, positive 42.5. All right, so just have it in your calculator because then after that it becomes easier. All right, so those are my 3 answers. Okay, perfect. So now I'll answer all of these questions. When f of negative 45 is equal to, so when x is equal to 45, it's equal to 3.6. Right, I'm going to do it the same for all of this. This one's 4.8. So when I do one, I'm just going to do all of them. 42, oh, sorry, 13.6. Right. All right, that means, so when he runs down 45 steps, he is going to lose, well, gain, sorry, 3.6, which means he runs up or down. So this negative 45, is it up or down? Down. And I'll answer all the questions down the same way. 15, is that up or down? That's up, because 15 is up. 42.5, is that up or down? That's up. All right, he will burn how many calories? So that's this box, right? So it's going to burn 3.6, that's 4.8 on this one, and that's 13.6 on that one. Okay. All right, this interpretation, or does it not make sense? Now, all it's asking you for is, if you look at this X values, does that make sense? So remember, what is X values? X values are steps, right? Does it make sense that he would run down 45 steps and burn 3.6 calories? Yes. Does it make sense that he can run up 15 steps and burn 4.8 calories? Yes. Does it make sense that he can run up 42.5 stairs? Can you run up half a stair? No. So that doesn't make sense. I can't run up half a stair. I can run up a full stair. I can't do half a stair. All right, so based on these observations, it's clear that the appropriate domain for the function. Now, in order to be able to answer these questions, we have to know these definitions. Now, instead of me telling you what they are, let me show you how to use Google. You need to know what a real number is. You type in real numbers. Real numbers are everything you can think of, including fractions and decimals. So it says real numbers are numbers which includes both rational and irrational numbers. So that means whole numbers, fractions, decimals, radicals, anything you can think of, okay? That's what real numbers is. Then you go to, so all real numbers will be both positive and negatives. Any number ever in the entire world that has ever been created is possible. Negative 2.385688910, whatever. All of that, that's all real numbers. Non-negative real numbers would mean take every number that's ever created that's not negative. So that would mean, 3.6834889, that's a non-negative real number. Real numbers within a constraint, meaning everything you can possibly think of between two possible numbers. Integers, okay, so you're not sure what integers means. So we come in and we type, what is the official definition for integers? So integers is all numbers not including zero, if I'm not wrong. A whole number, a number that's not a fraction. An integer is defined as a number that can be written without a fractional component. For example, 4140, and these are all integers. So integers is any whole number including zero, all right? And then whole numbers is, and they tell you 0, 1, 2, 3. Positive integers is 1, 2, 3. And then integers would be any number within your constraint, and any whole number within your constraint. So in this problem that we're talking about, if I'm standing on the stairs and I can run up or down, can I run up forever? No, because this is a real world problem. There's no stadium that goes on forever, right? So it's going to stop. Can I run down forever? No. So it's going to stop. So it's going to be between two numbers. Now, it is, what kind of numbers is that? I can't have half a step because we just talked about we can have half a step, right? So, but I could have negative numbers because I could have negative 45 steps. All right, so it's integers between a constraint. Remember, an integer is, whole numbers including zero, right? So -4 and 4, those are integers. So it's integers within a constraint. And they're asking you, what is that constraint? So based on the observations so based on just these observations, what is an appropriate domain? So what's your smallest x? -45. And what's your largest? Based on the observations, clear that the appropriate domain All right, so I don't think I agree with this answer, but it's okay. It's saying, so the thing we got wrong was that I was trying to say, what are the constraints? And because the question didn't give me the constraints, I just put in some numbers there to see what it would do. But it's saying that there are no constraints. But I think thinking in real world, the stadium has got to have a beginning and an end. I just don't know what that beginning and end is because I don't know what the stadium is. So or actually, you know what? Sorry, that's the calories. Yeah, so I don't know if I agree with this answer, but okay, I'll go ahead and take it. So they just talk to integers with no constraint. All right, so let's go ahead and do another problem, and it's okay to get it wrong. All right, so here's another question. So let's go ahead and put that in here. So we're going to type in y equals and your function. And instead of like changing the x, I'm just going to make it a table, because once I make it a table, I can put in the x value. So when x is equal to 2, so when x is equal to 2, y is equal to 8. When x is equal to 3.5, so I go ahead and put 3.5 in the table, 17. When it's equal to 9, 50. So I'm just evaluating it. So because this is a regular function, if you do the wheel table, you can just punch in the numbers and it'll tell you. So let's see what this problem is. In a board game, a certain number of points is awarded a player upon rolling a six-sided die, labeled 1 to x according to the function, where x is the number on the die. So now we know for if you roll a die, it's only going to be 1 through 6. So looking at my domain real quick, this is 2. Is that possible? Yes. Is 3.5 possible? No. Is 9 possible? No, because the die only goes to 6. All right, so now let me actually, because this I'm gonna leave till does the answer make sense too. So meaning when a 2, so what do we roll, right? Dies is the x. When a 2 is rolled on the die, the player is awarded 8 points. Does that make sense? Yes. When a 3.5 is rolled on the die, which does not make sense, he's awarded 17 points. When a 9 is rolled on the die, he's awarded 50 points. And that does not make sense. So based on this observation, the appropriate domain is, so what numbers can I have for x? So remember, x is the die, right? You can only have numbers 1 through 6. So, that's the difference. Okay, so integers, and you can only have 1 through 6. So remember, by definition, remember if you forget, an integer is like a whole number, both positive and negative. So boom. Excellent. Next problem. It just takes a second on these. All right, so I'm going to copy and paste this in here. So y equals, and it didn't copy and paste like I hoped, but that's okay. I'll just fix it. So y equals raised to the x, so shift 6, or you can hit the keyboard and hit that. All right, so there we go. All right, now once I have that, I need to evaluate it at -3, 48, and 7.5. So hit that, get the table. I need -3, which is, does it say round anything? Round to the nearest hundredth. Okay, so 2 numbers after decimal, so it'd be 38. So 192.38. All right, then we need 48, and we need 7.5. So 48, 2 numbers after decimal, 0.01, 0.01. 7.5, 2 numbers after decimal, 27.19. 27.1. All right, meaning, oh, now let me read the question. After taking a dose of medication, the amount of medicine remaining in a person's bloodstream in milligrams after X hours. So X is hours. So already when you're thinking about domain, think in terms of, can you have, 5.5 hours? Can you have radical 5 hours? Like start thinking like in that kind of general sense. So it's modeled by the function, find and interpret the given function values and determine the appropriate domain. All right, so f of -3 equals 192.38, meaning something hours, so -3 hours. Now, ask yourself that, can I have a negative hour? Is that possible? Can you have negative time? No, so this does not make sense already. All right, they are how many doses? 192.38. All right, when after 48 hours, meaning 48 hours, there is 0.01 milligrams. Does that make sense? Yes, I can have 48 hours and have milligrams. All right, after 7.5, how do we say 7.5 in terms of hours? 7.5. Okay, so 7.5, the dose is 27.19. Does that make sense? Yes, because I can have half an hour, right? But I cannot have -3 hours. All right, so because of this, what kind of domain do you expect? So think of hours of time, right? You can have 0 hours at no time, you can have an answer, but you can have negative, and I can have decimals as well on my answer. So it doesn't have to be whole numbers. So it's not necessarily whole numbers. Non-negative real numbers within a constraint. So there's no constraint in this because I don't know how many hours it stops. It's not the constraints. I can have positive integers, but I can also have real numbers, no constraint, non-negative. That's what I'm going to go with. Okay, so numbers that are not negative. Okay, and again, I chose that one because it's not just integers because I could have 0.5, because I could have 7.5 hours. And they just needed to be positive because I couldn't have negative. All right, let me do another one. So again, like I said, with this takes a little bit of practice. All right, so I'm going to put in that function, and unfortunately, this is the one I have to work out myself. So y equals absolute value. Oh, actually, do I have to? X minus 3. I'm in the middle of a recording. All right, so now that I have that, I don't think I can make a table. Oh, I can make a table. So make a table. All right, then you're putting in these functions. So I need -4. I need 1, and I need 1.5. And you go put in the answers right there. So -4 is 7, 1 is 2, and 1.5 is 1.5. Now I'm going to read the question. So it can be used to determine how far a number x is away from the number 3 on the number line. Okay, find the interpret the given. So this is how far a number x is away from 3. So if it's right here, it is 1, 2, 3 away from 3. So your x value is how far it is away from this number 3. So if it's over here, your x value is 1, 2, 3, 4, 5, 6. Okay, it's how far a number is from the number line. So looks like we can have negatives, we can have 0. Can we have decimals? Yeah, because if I put it right here, right, how far it is from here, it's going to be 1.5. So I can have decimals as well. Okay, so now that I know that my appropriate domain is going to be, and you can go in both directions. So it's just all real numbers on that one. Because I can go in both directions. I can have fractions, I can have decimals. All right, let me interpret this. So f of -4 equals 7. So remember, x is the number away from 3 on the number line, either left or right, doesn't matter. Okay, so -4 will mean I go to the 4 to the left, right? So meaning the number -4 is the distance, is the distance of x units. Oh, sorry, negative is, okay, so you have to read this different. Meaning the number is a distance of, okay, the -4 is a distance of 7 units away from 3. So if I go to -4 right here, how far is that away from 3? 1, 2, 3, 4, 5, 6, 7. So that makes sense. Okay, so this number -4 is a distance of 7 units away from 3. Okay, to give you a visual. This interpretation makes sense. All right, f of 1, meaning the number 1, is a distance of 2 units from 3, which makes sense. All right, so if I did and you don't have to draw it every single time. However, so 1 right here, 1 is a distance of 1, 2. All right, 1.5. So clear drawings, 1.5 right here is a distance of 1.5 away. So yes, it makes sense. So the number 1.5 is the distance of 1.5. And it makes sense. All right, so all real numbers would be what I would go with for that question. Good job. All right, I'll do another one because again, it just takes some getting used to. Even I had to kind of do a few of these before I got the hang of it. So y equals, and that's why we have practice, y'all. Y equals, boom. All right, then do a table, evaluate it at all these numbers. So where I need a -4, I need a 4 and a 3.5. All right, so at -4, it's 6,000. At 4, at -4, it's 6,000. At 4, it's 14,000. And at 3.5, it's 13,500. All right, let's see what this is talking about. A college has financial aid formula that applies to applicants whose family low income behind a certain threshold. The financial aid can be determined by this function, where X is the number of siblings, including half siblings. So what is X? Number of people. So ask yourself this question: does it make sense to have negative people? No. Does it make sense to have 4 people, 4 siblings, 4 brothers and sisters? Yes. Oh, I meant to say yes. All right. Does it make sense to have 3.5 brothers? No. You can have half a brother. All right. All right. So what am I thinking? My domain, because my domain is my X values, doesn't make sense for negative or for decimals. So that means I need positive, and I can have 0, right? because I can have 0 brothers. So I need positive whole numbers. Can I have 0? Yes. 1, 2, 3, positive whole numbers. All right, now let me go ahead and interpret what this means. So meaning a qualified applicant with -4 siblings in their household gets 6,000. Meaning a qualified applicant with 4 siblings gets 14,000. And an applicant with 3.5 siblings gets 13,500. And so it takes just a quick second to kind of read through this, but once you kind of go through it a few times, you're going to get it okay. I'll do another one just because, I don't know how many examples you need. So copy and paste once again. Equals, make it a table so we can put in our values, and I'll put in 1. So I already have 1 there, 5.5, oops, and 10. All right, so go ahead and put those answers in. So I've got a 9, 36, a 63. All right, so let's look at those numbers in terms of domain. What is 1, 5.5, 10 mean? So a board game set a number of points awarded a player rolling a 6-sided dice labeled 1 through 6. Okay, so my domain can only be 1 through 6. So does this make sense? Yes. Can you have 5.5? No, it's only labeled 1 through 6. So does that make sense? Can you have 10? No, because it's only labeled 1 through 6. Now looking at my domain, right? What numbers can I expect to have? So can I have 0? No. So I can only have the numbers 1, 2, 3, 4, 5, 6. So I can have not this, not that. I can have integers, but they have to be between 1 and 6. So between 1 and 6. So you click on 1 and 6. And what is that? Between 1 and 6. And now let's write down the rest of it. Meaning when a 1, your X is the face value of the die. So when 1 is dialed, the player gets 9 points. When a 5.5 is rolled, then the player gets 36. When 10 is rolled, the player gets 63. All right, so that's it for real world problems. I'm going to go ahead and do a couple of finding, increasing, and decreasing, because on these, sometimes people struggle with those as well. All right, so I'm going to use the video to do this. Determine the domain where the function is decreasing. So you need to know what decreasing means. So let me forward to the part of the video that this talks about that. Okay, I'll just go over it. Maybe it'll just be faster. All right, so when is this decreasing? So this is decreasing. When does it start going down? From here, you can see that this starts to go down. So that's obviously decreasing. What is that domain? What is domain again? X. So you just look at the graph from here to here, it's going down. Does it include those 2 points? Yes. So remember, if it includes the points, you do the closed ones. So it includes those 2 points, and it looks like it's 7 and 15. And hopefully I didn't get the 7 wrong when I wrote my line down. So let's take a look. Boom, nice and easy. Also, this is going to be real simple. All right, next problem. Determine the domain when the function is increasing. So when is it going up? So it goes up here to here. And then it starts going down, right? So it goes up from here to here. But it doesn't stop, because you see this arrow means it goes like this forever. So that starts from -infinity and stops at -1. Does it include -infinity? No, because we talked about infinity being open, but it does include -1. So it should be an open and then closed, -infinity to -1. All right, I'll do another one. All right, so once again, when is it decreasing? So you're going to look at when is it going down? So from here, it starts going down to, it doesn't stop. So this doesn't stop, is -infinity, and here is -4. So from -4 to -infinity, remember -infinity is open and this is included, so that's closed. So open and then closed, open and then closed, and the number is -4 to -infinity. Oh, my answer was not correct. So let me see, what did I make? Domain where it's decreasing. Oh, I am tripping, y'all. It's obviously -4. Is this also decreasing here? So it's all real numbers. Let me answer it first and then see. That's what I did, -4 to negative infinity. What did I do wrong? Yeah, I'm not sure why I got that question wrong, actually, because I said from -4 to negative infinity. Unless I tapped the negative infinity first. All right, so I can't remember what I tapped. All right, so when is it decreasing? So it's falling from here to about here, right? Excuse me, so that's -4. Now, how do I represent these numbers here? They go on to where? Positive infinity. So it's going to be open on infinity, closed on -4. So I'm looking for open and closed. And then infinity and -4. That's right. So infinity to -4. So what did I write wrong? Oh, does it tell, it's telling me I have to write it this way? I didn't think I had to write it that way. The function decrease when y values go down as x moves from left to right. Yes. Oh, I guess that's what it doesn't like. It doesn't like interval rotation. Oh, in terms of x, that's okay. I get it. My bad. It's from negative infinity. Okay, wait, I got it. I was putting in the wrong thing. All right, so when is it increasing? So it's going up from here to here, right? So this is -2. I was putting in this going down like this is what? Negative infinity, right? I was putting the y values, but because it's domain, I have to stay with x. So this goes down forever, but in terms of the x values, it goes left forever. So it's negative infinity. So open and then closed, open and then closed. Oh, that's the right one. Open and then closed, and it's from negative infinity to -2. Oh, that's a -1. I apologize. -1. I can't really see. That's -1. All right, we'll do a couple more since I got some wrong. All right, so again, domain is just your x values. Where is it decreasing? So it decreases from here to here. So this is 3. In terms of x, this goes on forever this way. So it's going on forever this way. So that's going to be negative infinity. All right, so it's going to be open and closed. So open and closed. And you're going to do negative infinity up to what number is that? 3. All right, I'll do maybe 2 more. All right, so where is it decreasing? Where is it falling? So it falls from around here, which it looks like it's about 5, and it's falling up to here, to 13. So from 5 to 13, and because it includes both of those numbers, it's just closed and closed. So closed and closed, and it's going to be 5 to 13 because domain is just the numbers on your x. Okay, one more problem. All right, so determine where it's decreasing. So where's the graph falling? So around here, so that's around 7, and it's falling all the way to 15. And it includes both of those, so we're gonna do closed, 7 through 15. Okay, that's how you do your work.